sort of manages the business logic and touches the view and the model. And typically you end up with events that lets the view know when the model has changed, so it knows to refresh, and also the view can use it to say there has been an interaction, and then the controller can be in charge. So that's one. Another one that has been popularized maybe with Angular and Ember a bit is the idea of data binding. And typically that's the idea of declaratively binding values between components. So there's one that's simply unidirectional. So it immediately goes in one direction from the view to the model. So any changes from the model to the view. So any change in the model updates the view automatically, and the bidirectional idea is going both ways. So the model is bounded to the view, but if you change it in the view, such as you do in Angular, if you change an input field, then that's going to update the model or view model immediately. So there's this idea of going both ways and keeping in sync. Another one and just one caveat here is that data binding only really works if it's synchronous. And that's something we're going to go back to. If you have something that you promise or asynchronous, it always gets a little bit icky. The next one is, and I'm sure you're familiar with the idea of virtual DOM, popularized with React. And that's kind of the premise is that, well, it's kind of troublesome to try and remember what state the DOM is in and what to change in the DOM. So let's just change everything. But the problem with changing everything is that DOM updates are very expensive, so we can't actually change everything, otherwise you have to redraw the entire page and it's really slow in terms of performance. So instead we're going to update this virtual DOM, which is an intermediate representation of the DOM that represents the DOM but in memory in JavaScript. It's just JavaScript objects. And then we can diff what the virtual DOM was and what it became, and then apply these as patches on the real DOM, which is a lot more lightweight. So that's what React does under the hood. And finally, and here we can see that there's also these events bubbling up. So if you've got a DOM event, it will typically be brought into the view, and then that you will catch it as a virtual DOM event that you can have listeners in your virtual DOM as well. So again, some events propagate that. And finally, the one that I think has been most recently popularized by Flux is this idea of the directional flow. And that's typically in contradiction to the bidirectional bindings, where sometimes it's hard to remember who's in charge of what the value. The state ends up being written to and read from, and it gets a little bit messy. So in the unidirectional flow, you have all these components that are in the cycle, in a loop that has no, it's a unidirectional cycle, which means that you always go in one direction, so it's easier to figure out where the information came from and where it flowed from. Again, we can notice that there's these red arrows when the dispatcher invokes callbacks in the store, and change events in the store mean that the view needs to be updated. So this is easier to reason about, but we still see that there's these red arrows, and that's the arrows I want to talk to you about today. It's this idea that there's a lot of event listeners, there's a lot of callbacks that happen, and typically this is just a materialization of this design pattern called the observer pattern. If you're familiar with it, it's the idea that you have a subject, something that you want to observe, and then you have components that are interested in this subject, so they're going to register observers inside the subject and be notified when the subject changes through these callbacks. Again, we can see these red arrows. This is not anything magical, you've used that all the time. If you set an event listener on the DOM node, that's an observer on the DOM node. If you use ng-change or ng-models in Angular, it's the same, or even in React, if you use the onChange, that would be sort of an observer that gets triggered as a callback. And typically we do that because we're interested in the state of the subject, because the component depends on the state of the subject. Maybe the component is just derived from that state, and you might even copy that state internally and remember to get updated. Every time the state of the subject changes, it will update the internal copy it's got. There's a couple of problems with that. Well, this is based on events, and we know that actually the problem with events is it's very hard to compose. So if you want to listen to multiple things, if there's multiple asynchronous things that happen either in sequence or in parallel, you want to compose them, it's really hard to do if you just have callbacks. And we'll get back to that in a minute. The next thing is you often end up, as we saw in the previous diagram, replicating state, which means that you've got a copy of the state and you have to sort of manually keep it in sync, and you might miss updates, and in general you have to end up sort of doing a lot of manual management of state, and that's because events are stateless. And finally, there's this problem of inversion of control. People talk about the inverted pyramid of doom or callbacks. But also in general, that means that if you look at the observer, it had to register something inside the subject. That means that you also have to remember to free it up, so you have to dispose of the observer at the end. And that's also a source of sort of errors and a lot of boilerplate. So what can we do? Actually, let's look at an example of that, because I think that's all a little bit abstract. So let's look at how that materializes in a simpler example where we have just one asynchronous thing that's going to happen. So it's just one callback that is delayed. Okay, not events, just one asynchronous action. So let's look at this example. So this is like a canonical example of what we do on the internet. We just find pictures of cats. So here we've got 3 colors in an array. By the way, this is year 6, so hopefully that's comprehensible to people. It should be pretty natural. And so we try to find, you have this find cat function that takes a color and takes a callback, and then when we receive it, then we're going to invoke the callback, either with an error if it errored, or with the source of that image of a cat that we found. And then for each of the colors that we had initially, we're going to call this, and then we're going to aggregate the state, and we try to post the list of these cat pictures back to another endpoint. Okay. So the first thing we notice is that there's no return value in this find cat thing, because there's a side effect using the callback. So there's no return value, it just returns undefined. The next thing is that we have to sort of manually manage the fact that they're all running in parallel and aggregate the states inside maybe this intermediate mutable variable array. And this doesn't guarantee order, so it's again another problem with that. So it is quite fiddly to sort of build up the state of these asynchronous things that run in parallel. It's also fiddly to detect when we're done, so we have to sort of see, well, have I got as many as I expected? Yeah, okay, so I'm probably done now. And again, we can see that all of this is nested, so it's kind of veering to the right more and more due to this inversion of control problem. And finally, there's also the error propagation. It's quite fiddly. You have to do it manually, like forward the errors every time. This is quite a contrived example, but I think you probably realize that you've got these things in your code everywhere. So how do we solve this in the case of callbacks? Well, I'm sure you all know the answer here. So the simple solution to this is to use promises. So if we take the same example with promises, we still have these colors and we still have a find cat function, except this time it returns something. It returns a new promise. And we can use this then construct. Is everyone familiar with promises? Anyone not familiar with promises? You can raise your hands, okay. Okay, cool. Then means that we're going to take the value that's returned. So here the promise is, it encloses the value that is going to come back, which is this image object. And here we can use then to map that value and transform it into a new promise that at this time contains the source of that image. So that's a new promise that's returned by find cat. Then we can see that we map every color we call find cat, so that becomes an array of promises. And because we have an array of promises, we want a promise of an array, then we can use the promise.all combinator to join these multiple promises and wait on all of them. And once they all come back, we get an array of all these values. And we can also see that we can flatten the then. So because this is then, if the then block returns a promise, it's going to get, as we say, flattened. That means that it's not going to be a promise of a promise. It's just going to be a promise of when that promise that was returned completes. And that means that we don't have to do complicated stuff. We can use that to just wait. And once this host is terminated, then we're going to alert to say that, okay, great, we've sent. And as we can see at the end, we can catch the errors at the very end, so that we don't have to do it everywhere. We don't have to do it manually. We can just catch them the same way you would do with the try catch. Okay? So we can, in a way, we can say that promises are the idea of a deferred value. So it's a value that will come eventually, and we have this wrapper thing that contains that value, that promise of a value that eventually resolves. But that's not quite what we want, because what we talked about were events, but events don't happen just once, they happen multiple times. So instead what we want is something that we call observable streams. And rather than a deferred value, is going to be the idea of a time-varying value, so a value that varies over time. So let's take an example. So that sounds a little bit like a sequence, right? And there's one type of sequence that you probably know about, and it's the idea of an array. So an array is just this sequence in space. So if we take the sample numbers 0, 1, 2, 3, we can represent it as this the direct sequence of values, and simply the sequence is indexed in memory. Okay, and we know that we can actually transform this. We can do something like map, for instance, where we map n to n plus 1. That means we're going to increment, and this is going to return a new array that contains the same elements but added incremented by 1. And then we can also filter it. So if we divide it by, if we take the modulo and we keep only the even numbers, then we end up with this smaller sequence of just 2 numbers. So that's a sequence in time, but what we want is something that triggers over time. So it's a sequence in time, and that's what streams are. It's this idea of a sequence that is triggered, that has values over time. So if we take an example here, we're going to use RxJS, as I said. So there's this little helper function called interval that simply fires a new value, an incrementing integer, every 1,000 milliseconds. Okay, so every second. So every second, we're going to get the value 0, 1, 2, 3, and so on. And this is, so we can see that this time, the axis is actually time, right? So every second, we fire a new value. But we can do actually the same thing as we did before. So we can increment it by doing a map to n plus 1. So then that returns a new sequence, a new stream, except that each value is incremented by 1, and it fires at the same time. Or we can filter it the same way as we did before, and you end up with a new stream that fires every 2 seconds with even numbers. But because it's a sequence in time, we also have methods that we can apply that affect time. So for instance, we can delay it by 1 second, and that's going to mean that it's going to be shifted just by 1 second and fire 1 second later. So these are called marble diagrams, and they're quite useful to represent streams. Yep, you got a question? Oh yeah, so that's the convention that I just adopted from, I think the Psycho.js uses it, and it's just to figure out whether something is a stream or not. It actually ends up being quite useful because you remember whether that's a stream or not. The last operator I want to show is flat map, and that's what I said earlier about the way then flattens promises. If a callback returns a promise, we can do the same with an observable, except we have to use this flat map operator rather than map. And that's just something to remember, but it does exactly the same thing. The other thing that I forgot to mention on the last slide is that, as you could see, it was actually an infinite sequence. So how do you deal with infinite things? So the reason that works, and it doesn't sort of loop infinitely when you try and consume it, is because it actually uses, it's lazy. So that means that nothing is actually done until you subscribe to it. And this, we can see here the pattern to subscribe at the end. So typically you subscribe at the very edge of your program, and this is what starts pulling values out of the stream. Okay, this is quite a useful website called RX Marbles that you can use to visualize different operators using these marble diagrams. I recommend having a look if you want to know how these operators work or what they do. Okay, so that's great, but what does it have to do with building web apps? That's all sort of abstract. So what do we do when we build web apps? Well, typically we said that we respond to events, but events are just sequences in time of things happening. So an event is a stream. So we can model an event as a stream, as we do here. So let's just build a small example where every time you press, we want to sort of maintain a total number of how many times you press Control plus and Control minus. It's not a very interesting program. Let's just take it as an example. And so the first thing we do is that we create a stream from the DOM events key down. Every time key down is pressed, that's going to emit a new event in that stream. Then we can filter it by only when the control key was pressed, because we're only interested in Control plus, Control minus. So we want to have a stream of key downs with the control key pressed. And it's going to, and then we can map it to the char identifier, so that switch character was pressed, and we can filter it by the ID of that identifier. So either this is the Unicode for plus, this is the Unicode for minus. So we end up with 2 streams, one for every time you press Control plus, and one for every time you press Control minus. The value is emitted through that. So we wanted to increment when it's Control plus and decrement when it's Control minus. So we're just going to map these values to the offset. So we just want to add 1. So every time it's Control plus, it's going to be a stream of 1s, and Control minus is going to be a stream of -1. So we've got all these offsets now. What we need to do is sort of sum them up incrementally, right? And if you've done that in an array, you probably use something like reduce, except you want more like scan, because scan is like reduce but emits a value every time it sort of adds up. Oh, yeah, sorry? Yeah, that's correct. That's wrong. Thank you. So here the total, we're going to take this offset and we're going to scan starting at 0, and every time we're going to every time an event, 1 or -1 passes through, we're going to add it to the sum, and we're basically going to aggregate the total here, and it's going to be a new stream of the total, and we can subscribe to it, and then you're going to get something like this, where you get the value going up and down as you press the keys. So we see that we've modeled events as a stream, but we've also modeled, more interestingly, the state as a stream. Total is a stream. It's not something you mutate. There's no mutation here. There's no assignment, there's no var, everything is declarative, and it's done as a stream. Okay? So this is all good, but how do we do that with the DOM? How do we do that as a web app? So let's have a look at a small example where we're going to build, actually let's look at this diagram first, I forgot about it. So we're going to do something similar to React, where we take the model and we express the view as a function of the model, except this time, this relationship will be expressed as a stream. So let's build a simple clock UI, just something that gives us the time. That's easy. So first we import Rx, so this is the Rx.js library. We import moment to do a bit of date stuff, and we import H, which is this virtual DOM library. It's a standalone, lightweight virtual DOM library that's very performant, and that's going to help us create virtual DOM elements. So we create a ticker, so that fires every 50 milliseconds, and we can see that the corresponding values, every 50 milliseconds we're going to get 0, 1, 2, and so on. And the time is simply mapping that ticker to a new moment, so a new date that is now, and then formatting it to be hours, minutes. So that's going to mean something like this. So, and then also we only keep distinct values, so we don't have to emit every time when it doesn't change. So we end up with something like this. So 2 is 36, nothing for 1, and then 2 37, and so on. That's just a stream of strings that represent the time. And all we want is to put that in the DOM. So let's create a virtual DOM out of it. So we map that time string onto this H. This is creating an H1 tag that contains the time in it. So we end up with something like this. So this stream of virtual DOM elements that contain the time in an H1. Okay? So that's great, but we still haven't printed anything in the DOM. We still haven't. So how do we apply this into the DOM, onto the DOM? This slide is a little bit advanced, so don't worry if you don't get everything. It's just to show that it's actually very powerful what you can do in just a few lines of code. So we have this tree, which is a stream of virtual DOM elements. We're going to import a few more libraries, so diff and patch from the same library and then virtualize. So the first thing we do is we locate what DOM element we want to be outputting into. Let's call it out. And we virtualize it, which means that we take that representation and we copy it as a virtual DOM representation. So we have something like this. Maybe it's an empty div to start with. Then we're going to express vDOM as a sequence that starts with the initial DOM and then contains all of these tree elements. So that's going to be something like this. So it's initially it's this initial DOM, but then we're going to have these different time representation of the virtual DOM. So that's the stream vDOM that represents essentially the sequence that the DOM is going to have in time. And now what we want to do is we want to find a difference between these two and then the next two. So to do that, we're going to buffer with counts, which means that we're going to get something like this. So we're going to get the first one and the second one, and then the second one and the third one, and so on. So we get just pairs of them, which means that we can now diff them. So we can apply diff on the previous and the current. So that's going to give us a patch using the diff returns a patch that tells you how to transform from one virtual DOM to the next virtual DOM. And then we can use reduce to reduce onto the DOM, and we start with the initial DOM, so we start with out, and then we patch it sequentially. Every time that it fires, we patch it, and that means that we apply that patch from this element to the next. That's going to transform the DOM in your page efficiently. So that's basically the framework, right? So that's how you do the virtual DOM using streams. Oh yeah, and finally you have to subscribe to kick everything off. Okay, and then you end up with something like this. Not very impressive, but yeah, that's just the start. So now, actually, well, this is all good, but we saw that there's still no user interaction. We haven't talked about how do we get the people to interact with the page. So we have something like this. So we have the model, the view expressed as a function of the model. So we can actually write it as the view is a function of the model. And it takes the model the time and maps it and so on, and returns this tree, which is going to be applied to the virtual DOM. But what do we do with these DOM events that come back from the DOM into the view? What we can do is we can model them as a stream as well. So we can see here that every time someone clicks on this element, we're going to fire these events into a subject, which is a way to pipe new elements into a stream, and then we're going to return that stream as that's going to be an output of the view. So the view, two things come out of the view: the virtual DOM, the tree, which is going to go onto the DOM, and the event stream, which is going to be passed onto what I call intents. So intents are sort of what the user wants to do what actions the user wants to take on the model. So here, well, simply we're going to map the clicks to just a simple value because we don't actually care, it's just a click. So we just want to have this value firing. And then finally, we can apply these intents back onto the model, and we can so that means we have expressed the model as a function of the intents, and we're going to use, I've collapsed the code here because it was a bit bigger, but essentially the time will be a function of the people clicking on it, and you can see that then you can toggle using the intent stream. So this is what I call the reactive loop. It's this idea that each of these is a function of the previous one as a loop, and everything is closed, and the only side effects are the ones that are applied and come back from the DOM. Okay? The full code for this example is down here. So it's time to do some live coding, so wish me good luck. Okay, so we're going to start, and the idea is to build a small interface to search for images, okay? So we're going to start, this is what I've got initially, so I've cheated, there's already a little bit of code. But all there is, the page is pretty empty and everything is built using this JavaScript here. So we bring in the libraries here, a few helpers. Just this is Rx observable alias because otherwise it's too long to type. We have this small search function that returns. So if I send a query string and a flag whether the image needs to be free or not, it returns asynchronously a stream of one element, and that element is a list of images. It's a bit like a promise, but just as a stream. And we've got this inputs component, which is this thing up here. I don't want to show all the code because it's a bit boring. That's the reactive loop I showed earlier, but it looks something like this. So it exports the value that as a stream, that is the value in here. Obviously, it doesn't do anything because we've not done anything yet. And then the tree is the virtual DOM that represents that input element. Same for the checkbox. And at the end of the document, we can see that there's this code that I showed earlier to render the tree from the view into the DOM using this sequence of events. Okay, so let's get started. So here we have this view, and we can see there's two things in it. There's the filters components, which are these two filters at the top, and then the results list component, which is these results here. But currently there's nothing happening. So the first thing to do is to see what in this filters component, we have the two things exported as streams, so the query and free, which represent the values of here. So let's pick up one of them. So if we define this, and we're going to just alias it for convenience. So this is the query stream, and let's pass it into the results because I want to say what I'm going to be searching for. So I'm going to pass it in here and receive it here. So this is the result list component that outputs this element here. So currently there's a heading, but it's just this one stream that returns just one value, the H2 search result. So that's a bit boring. What we're going to do is every time the query changes, so we want to map from the query onto a new virtual DOM element that's an H2, and here we're going to output the query in it. Okay, so we can see that there's this, oops, I forgot one double quote. So we can see that now if I type in here, So it's going to update immediately here, okay? So that's just because I've taken the query and I've mapped it. So the heading is now a function of the query, and it just injects the query value here and returns that as a virtual DOM element that is exported as the tree for this result list component here. Okay, so that's still not very interesting because we want to see images, we don't care about anything else. So we want to send a query to this search function. So let's build the query first. So the query is going to be simply an object that has a query, a parameter, and maybe a free parameter. So it's going to be a function of the query. And I'm just going to use the ES6 shorthand for the object. So that's going to be an object that contains the query every time the query changes. And we can also, and then that's the query, so we want to run it to get the results. So the results is simply applying this query to the function I showed earlier. So let's write it like this. And the search was called search images. And we pass this search query in. But actually, as you see, this returns a stream, so we can't use map, we want to use flat map here. So let's use flat map. In fact, I'll just even use flat map later, so don't worry about the difference. So we have these results, we still don't do anything with them. So we want to show them on the screen, obviously, so we want to show them as part of the result list, so we're going to pass them in. So we pass the stream of results in to the result list component, and now we can receive it here. And well, we're only showing the headings here, so let's show something else. Let's show the result list as, let's do something simple. Let's just show the total results we've got so far. So that could be like a span with results.total. So that's the new element that maps. And now we can see that this is a new stream of spans that contain the total number of results, but it's still not being injected at the page because we're just discarding these values. So we want to actually combine it. The output of this result list component needs to include it. So I've got this little helper that called container that takes streams of virtual DOM and wraps them in an element here called div. So let's just do that. Okay, so this is the number of images. We've got about 2 million images. This is the live production database from the guys in widely used test environments. So we can search for things and we can see that it automatically updates. Cool, so we've got live results, but that's not the most exciting way to show images. So maybe let's show the actual images instead of the total. So if you want to show the images, we need to wrap them. So maybe let's put in a div, but we need to show them all as individual elements, right? So for each of the results, let's do that. So for each of the results, we want to wrap it in this, and actually I've got a small image cell here that's going to render one image. So given the source, I just have to extract it. It's something like this. And then I'm just going to call image cell with that source. So that's the images. Oops. Let's just return that inside another div again. Okay, going back. Okay, so here's the images. So that's just image elements, and I can search for, I don't know, a cat, and it immediately updates. We can see that it's actually it's a bit fast, so it updates every single time I type something. So the first thing we can do is actually debounce that. But if you've done that before, it might be a bit fiddly, but here, because it's a stream, debouncing is just another method on it. So we can just debounce 500 milliseconds, and now if I type, it waits 500 milliseconds and then it emits the value. So you can see that it's really easy to compose asynchronous bits on top because everything is an asynchronous stream. Can I rewind that? Oh yeah, the other thing we haven't brought in was the free flags. I can cover this, but it doesn't do anything. So let's just quickly add it. So we simply want to extract the free stream, which is a stream of booleans out of the filters, and then we're going to combine it. So here we have to combine it, so we can use the observable.combine latest function, which fires every time either changes and emits a new value every time either of the arguments change it. And so if the query of free changes, and that's how we combine the results. And then now if I toggle it, you can see that more or less images are returned. And obviously it's every time, yeah, either changes, the results change. Okay. So that's nice. But one thing that makes it look more fun is if it's a live result. So if things automatically are brought in. So let's just have something called a ticker. So just a stream that ticks every second. Say every second we want to update it. So we start after 0 milliseconds, and every 1,000 milliseconds, every second, this is going to emit a new value. So now if we add this to the combine latest, that means that it's going to trigger a new. This stream is going to emit a new value every second. So if we put it in here, we should see that hopefully there's image coming in. Yeah, so we can see that every second new images, if there's any, there's not always new images, might get brought in. Now the last thing is that we can see it's a bit brutal the way this is like it's not very elegant the way images come in. So we can try and do something a bit more fancy, which is to make them fade in. So that would be quite fiddly to do if you used anything but this touch DOM, because you have to sort of know when the images arrive and maintain state about that. But here, it should be pretty easy. So let's have a look. So here, the problem is that what we want to do is we want to add, I've got a bit of CSS to make it, I've got a class, I just want to use CSS animation or transition between two classes. So the class is going to be, if it's loaded, so let's call it class. So if it's loaded, then it's just going to be image loaded. If it's not loaded, let's just say it's image loading. Then we're going to add this class to here, to the imager. So fine, but we're still not feeding that. So how do we know whether it's been loaded or not? Well, we can use a little helper. I've got this little helper that I've loaded at the top, which given it's called preload image, and it's going to fire as soon as the image has been loaded. So it tries to load it, and then once it's loaded, it just fires one event, and this is again returned as a stream. So we just pass it, and that fires as a stream. So basically, we know that once it's fired, once this thing has fired, and we discard the value because the value that it fires is not important. What is important is the fact that it has fired. So once it's fired, we know that the source is the same, but then it's loaded, so we can pass through. And before it's fired, so until then, we can start the stream with the same cell, except the image is not fired. So we can just pass false. Except now we saw that this actually returns an observable, whereas previously it returned a value. So this now is actually a stream of observables. So we can't actually the virtual DOM doesn't know about observables. So we have to use this container thing, and it probably won't work. It doesn't work. This is where it starts to go wrong. Yeah, so the problem was that because this is now an observable, we need to use flat map, as I said earlier. So let's see what happens now. Does it? Oh, it doesn't work. That's sad.
Seb, it's your pen.
Sorry?
It's your pen.
Yeah, all right. Here we go. So we can see that, I don't know, it's set for Obama. A bit too fast. yeah, you can see that it fades. I don't know why it's not fading properly. But, yeah, you can see that it's fading now. So yeah, the class is added, and then it's being updated as soon as the image has loaded. So that's how we're doing it, simply by hijacking when the class is added here declaratively in that result-is component. So that's all I've got for this demo. So it didn't go pretty wrong. That's very nice. Okay, so let's resume. So we ended up with something like this. So we can see that there's these filters where one module that contained more inputs and so on, and then the results was another component. And what's interesting is we can see that the state of the query originated from the input and was sort of passed around here and passed around into the heading, but it was not copied, it was just you hold the reference to the stream so that you can simply use it. When it changes, you can simply keep updated with it and map onto it, what you're trying to do with it. And again, the same with the free, and then the results were combined here in the top level of the view and passed into the image results. And it was all of this was done without observers. It was simply by mapping, saying every time this changes, I express everything is expressed declaratively from the things it depends on. And I think that's one of the key ideas of this reactive loop, is this idea that with reactive programming in general, the idea is to be fully declarative. So that means that dependencies are explicit. You're not just keeping a reference of something else that you don't own. You have to have an explicit reference of it, and then you can react on when it changes by simply combining it with your own stream or the values you depend on. And that makes the ownership a lot clearer. Nobody can mutate that stream or that value. It's only mutated at the origin. If you need an altered version of it, you just create another stream from it. And you can also, it's actually quite performant because I think, especially contrarily to React, which doesn't know when things change and just you have to manually implement like should component update and horrible things like that. In this case, it's simply evident from whether the new value has been emitted in the stream. And finally, because it's all streams, and streams are sequences in time, everything is very asynchronous natively, and that makes it really easy to do things like throttling, flat map. If you're waiting for asynchronous results like we're going to do in the dojo, and composing these streams together we saw with the combine and containers, that was really easy. So that's something that is normally really fiddly to do. So that's all I've got. So in terms of what we could go next with this, so I want to explore more. I mean, this is still kind of an experiment, but I think it's good to play with and discover what we can apply in general. And more things we could do with this is to make it update the URL, so this idea of like router, or how do we unit test these elements? As we can see, there's no side effects, so it's very easy to test. Unit test them because the output is a function of the input, and that's it. Create a library of reusable components, so simply you can compose components that exist rather than having to implement your own input and checkbox and so on. Another idea that was quite played around is the idea that you can actually do much of this work in the web worker and then post just the diff back onto the main UI thread and apply it to the DOM. And that's a really cool idea where you could see that a lot of the grunt work is done off the UI thread, so it doesn't slow down the rendering because everything is done in memory anyway, so it's just streams and data being processed. And using a request animation frame to apply that to the DOM when it's most efficient and see how that works with web components. That's kind of ideas I've got to explore next. So as a conclusion, I think for me it's not about selling like you have to do everything with this now. I think I don't want to give an answer, I want to open up questions. So I think people should think more. There's no silver bullet for all problems, but think of what is best in your case. So here we saw that we built this whole thing simply with libraries. So don't jump to a framework immediately because it's cool, it's in Hacker News. Think of, can I actually just use small libraries to do the work? And is it going to be easier to maintain? Also, can I use reactive programming instead of the observer pattern because it makes asynchronous a lot easier to deal with, especially when there's state involved. And you don't have to do everything reactive. You can start small. You make sure you use promises. You can compose reactive extensions with your own framework like RX Angular and things like that, or Bacon. So there's a lot of things that let you use it in day-to-day life without having to go all the way. A couple of references, I'll let you, the slides are online, so the slides are here, and the dojo we're going to do next is here. That's all I've got for you, so thanks for listening, and we're also hiring, so if you're interested, we do a lot of reactive stuff for The Guardian and functional stuff, so please come and talk to me. Thank you very much. Don't know if there's any questions. Yeah, Rob?
If you're working on a new project, would you choose this over Angular, or would you sometimes choose Angular, and if so, why?
I don't think I would choose this for a massive new project that might have to be very big. I think this is good for trialing with smaller projects until proven to be scalable. But I think I would definitely want to pursue it more and more projects of increasing scale. I think comparing it with Angular gives you a lot for free. Like especially if you're going to use the new version. I think it's got a lot of optimizations and gives you essentially a framework that is hence the name to work in and conventions to follow. It's kind of the same with React. So it depends whether if you're trying to do something small that pushes the boundaries, I would try and explore something like this. But otherwise, it might be a safer bet to use frameworks. But again, as I said, it depends. So. Yeah.
So you put RxJS and Virtual
Mm-hmm.
What's the difference between those and Bacon and React?
Yeah. So Bacon is an alternative to RX. It's very similar. I mean, I've used both. I kind of prefer RX now because it works in different languages in a similar way. So it's got this kind of breadth. And it's a bit more formalized, and the API docs used to be horrible, but now they're actually really nice. So it's just it's a bit random, but I think
You could have one or the other.
yeah, you could have one or the other, and people have used both and have been successful with both. In terms of React, I think React imposes a lot more. So there's the idea of these views, and then the whole framework is a lot more prescriptive. This is like VirtualDOM literally just deals with VirtualDOM nodes, diff them, and then apply the patches onto the DOM. That's all it does. So it's a lot more thin as an API layer, which is better to work to build on top of, I think. I don't know enough about React to say how I would implement, sort of, say with Bacon.
I think it feels like more boilerplate with Virtual than React.
There might be, I mean, you can use JSX to produce VirtualDOM elements, I think, like using that library. So I think you can combine them if that's what you prefer. There was one more back. No, yeah.
I was just wondering about have you tried experimenting with doing some JavaScript animation with these streams? So because you had that image loaded, it was like a boolean, like you had the stream of before they were loaded, and it starts with
Yeah.
the stream of okay, I'm done, and then you fade them in.
Yeah.
I'm wondering if is there presumably there's I haven't used, but you have that interval in RX, which is like every second. Is there like equivalent of like an easing, so it would be like faster than
Yeah, I think you could do that in animate opacity, for instance. I suspect that JavaScript timeouts are not very precise, so it's probably more precise to rely on CSS, which will be implemented natively and tap into the graphics card. So that's why it's probably more efficient and easier to do it that way. But it would be interesting to test how efficient, especially if you start tapping into web workers and request animation frame to see can you do the stupid flipboard thing. Yeah.
So if you wanted something to fade out, for example,
Yeah.
so you had a list of your images. So I'm just asking because I'm using React and I'm using this timeout transition group that's
Yeah.
and it's a bit icky because you say the result of my render is the thing is gone, but React keeps it like in the DOM while it's fading it
Yeah.
away. I was wondering how would you approach that, because your results, you're mapping over the results, and if the
Yeah.
one you want is gone, but you want to keep it, but you want to fade it out.
Yeah, so in the map, we could have done a flat map where you, as soon as the preload image is finished, then you would fire a sequence of, and every 10 milliseconds, I'm going to emit a new opacity and sort of could tone the opacity down or up. So you could do that. We'd have to. Sounds like I'm going to try it in Dojo. Yeah. So that'd be interesting to see how it performs and how it renders. Cool. Yeah.
So obviously a lot of this is inspired by the confusingly named Andre Medeiros' Cycle.js framework.
Is that his name then? I thought it was Andre Stoltz. So.
Yeah, no, his GitHub name is Andre Stoltz.
Okay.
But his name's Andre Medeiros.
Yeah.
I work with him. Anyway, I was wondering, because you recommend using these individual libraries instead of using a framework. Do you think Cycle is one of those kind of like big frameworks that like makes it more difficult to reason about things, or is it an applicable tool in this case?
Yeah, so Cycle is the Andrew's implementation of this, which he formulated in his blog post. I don't think it is one of these big frameworks to avoid now. I think that's definitely something I'm interested in it as well. I think he's taken a slightly different direction, and I think it's interesting to see both. I think both are sort of imperfect in different ways. I think it's mostly the question of how you deal with closing the loop, which is obviously as difficult as A depends on B depends on C depends on A. So how do you define this? That's always a bit tricky to do, and also how you deal with the side effects or how you isolate them. I think in Cycle is the way it observes the way you register the listeners seems to be a bit inefficient because you have to query the DOM every time. At least as far as I saw in the source code, but I think that's that's not really a main issue. You can delegate it. So I think have a look at both and see what you prefer. If sometimes, as I said, frameworks give you a bit more structure to start. So I think that could be a good thing. I would probably not encourage people to reinvent everything from the bottom up every time. So yeah. Patrick?
You mentioned that you want to explore web working in combination with this pattern next. Do you want to allude to explain a bit further? Do you mean just what would you do in the web worker? Would you compute the virtual DOM output there and then keep your
yes,
or are you going to be doing the actual stream observable application logic inside the web worker and only send out your virtual DOM disk?
Yeah, I think ideally, putting as much as possible in the web worker would be interesting. The problem is obviously the interface with the DOM. You still have to have the listeners bind to the normal UI thread and then somehow forward that into the web worker. So I haven't really tried it. So that's something more like have a play and try it. But that's something that would be interesting to try, especially because through these streams it's a lot easier to forward data around without losing track of the state.
Yeah, I was wondering what kind of user interface problems you found this was tricky to apply to.
It's tricky to apply to. I don't think I've used it enough to encounter that, so can't really answer that. Which is not to say there's no flaw, it's just to say I have not used it enough, so I don't know yet. But I'm sure there'll be, as everything, this sort of trade-off stuff. Yeah.
We use a server service side. If you had to get data, maybe have an express service.
Yeah, that's a good question. Whether you can do it sort of in an isomorphic way. So I think, yes, you could do it because it's all. At the end of the day, you just end up with a merged DOM, and all you can do is transform it into a string, and that's your DOM. So you can do it, and I think Cycle would do it if I remember correctly. So run Cycle on the server. So yeah, you can do it. I've just not tried it, but that's something you can explore. Yeah. Any more? Ready to be coding? Cool. Thank you. So if you go to that address, so deeper/fun.js reactive loop, the idea is to do a small Twitter client. Except, is there a way to use the user streams on the web?
You have to register for it.
Sorry?
I think you have to register for it. You have to, you have to go right to the channel just because of capacity.
So I tried to do that all weekend and it didn't work. So I've created a fake user